In this video, I want to talk about long-run value, or sometimes a limit. And the first thing I guess I want to kind of build to that is I want to talk about recursive sequences that kind of do two things at once. So you can see here I've said, okay, my first term in my recursive sequence is 16. That's my starting value. And to get the next term, I'm going to take my value, multiply it by 0.95. Now let's just think. Multiplying by a decimal should make my number smaller. Then I'm going to add 16. Well, let's do that. Let's see what happens when I do that. All right, so what I've done here on my calculator is I have put in 16, and then you can see I did 0.95 times 16 plus 16, so exactly matching kind of my recursive equation here. I'm going to hit play on this, and I want you to just watch what happens as I begin to hit enter. I'm just going to keep cycling through. And I actually just kept going. I said right the first four. But I want you to notice that as I keep going up, the amount that I'm going up by starts to shrink. I'm not going up by 16 anymore. I'm going up by less. And at some point, I will reach a value where I just keep hovering at the same number. You see how that increase just keeps getting smaller. Okay? Let's look at the second one. So here we've got first term of 450, and we're multiplying by 0.85 every time, and then adding 45. Let's use my calculator to model that. All right, so here you can see I put in 450, and then I said, well, 0.85 times that answer plus 45. This is the way we can use our calculator to do recursion. So let me hit play on this, and it'll start cycling through. And this time it actually is smaller. But again, you'll notice that what it's going down by gets less. 8, and there's 6, and there's 5, and there's 4, and there's 4, and there's 3, and there's 3, and there's 2. It keeps getting less and less. So this leveling off point, either as a growth like this one, where it kept getting bigger but by smaller amounts, or this one where it kept getting smaller but by lesser amounts, that's called our long-run value, or our limit. So I want to talk about how we can calculate that, but first let me just explain, because we've had an arithmetic and geometric sequence, and you see that this part has both. We're multiplying like a geometric, but then we're adding like an arithmetic. Multiplying like a geometric, adding like an arithmetic. This is called a shifted geometric. Okay? Now, the way we solve this comes down to a very simple idea that sometimes is a little difficult to remember. The limit, or long-run value, happens when we reach it when our input, what we put into our equation, is equal to our output. Whatever value we put into the equation is what we get out. That is how we know we've reached that long-run value. Well, it's actually, like I said, a big idea that's pretty easy to calculate. This is our input. This is our output. They just need to be the same. So the way we can solve this, the easy way we can solve this, is simply to say, well, when is my input, I'm going to just write x, because that's what we usually write, of course, for unknowns, equal to my output. Remember, we're interested in where these two are the same. So we just replace both u sub m and u sub n minus 1 with x. And then we just solve. So subtract 0.95x from both sides. Remember, this is 1x. So 1 minus 0.95 is 0.05. Divide by 0.05. And this calculates to be 320. Here's what that means. If I plug 320 in right here and add 16, I get 320, which creates like a loop. Because remember, a recursive says, well, just plug in the last number to get this number. But now I'm constantly plugging in 320 and getting 320. That's my long run value. So as this thing grows and grows and grows, and you saw my calculator output grow, as it gets closer and closer to 320, that growth will just keep getting smaller and smaller. And when it reaches 320, it stops growing altogether. So let's do the same thing for this second one. Again, we want our input and our output to be the same. So we just basically replace those with x's. I'll do it here, but then we'll also write it below. So we're going to say x, I'm going to put my work down here, equals 0.85x plus 45. Just remember this is 1x. So we subtract 0.85. Well, 1 minus 0.85 is 0.15. Divide both sides by 0.15. And we get 300. Which again, that was what we were approaching. Remember, I was at 312. It kept getting smaller and smaller. Once this reaches 300, if I plug 300 in, 0.85 times 300 plus 45 will exactly be equal to 300, and that creates this loop. Okay? Always replace your 2 un minus 1 with x's and solve. Should be a quick, easy 2-step solve. Just got to remember the process and remember why it works. We want to know, when do we create the cycle that the input and output are the same? Let's do one more. All right. Forever Green Nursery owns 7,000 white pine trees. Each year they sell 12%, for holidays, something like that, maybe for people in their lawns. So they have to plant new ones. Okay. So if they sell 12%, let's start with that idea. They're losing 12% of their trees. So we do one, remember, we always do one plus or minus, but we're losing. So we're going to subtract off 12% to figure out our multiplier. So our equation is, all right, maybe I'll put a 1 here to say for first year, we had 7,000 trees. And first idea here is, well, we're going to multiply by 0.88 because we're going to lose some trees. But then we're going to add 600 more. So how many trees are there after 10 years? Well, let's use our calculator to figure that out. All right, I put in my 7,000 trees. See, I set up my formula to say take that 7,000, multiply it by 0.88, and then add the 600. Let's start the running here. So there's 2, 3, year 4, 5, 6, 7, 8, 9, and 10. So 5,632. I went one more. Okay. So that's how many trees there are, 5,633, I guess, whole trees in 10 years. Now, what this probably nursery would be interested is, where's the leveling off point of this? Where is that amount going to be in the future? What's the perfect mix where whatever we lose, we also gain? Okay, so we're going to go to that long run value. We're going to take our 2 pieces here, and we're going to replace them with x's. Now, I might, just to make it look kind of the same as we're used to, I think I'm going to put that 0.88 in front of my variable, because that's what we usually do. Okay, subtract 0.88 from both sides. Remember, it's a 1x. Divide by 0.12, and we get 5,000 trees. So that's the level off point. Now, I guess I also want to just point out kind of how this relationship works, because this all works together. 12% of 5,000. 12% of the 5,000 is 600 trees. So this is where we meet the perfect spot where the trees that we sell is replaced by the exact same amount. Okay, so we almost started with too many trees. 7,000 was more than we needed. Okay, so that's why 5,000, the 12% we sell will exactly be offset by the 600 we plant. Always remember, long run average, just replace your two pieces with X and solve. We just want to know, when is this equal to this? If this video helped you, please like and subscribe for more math help.